Certifiable solutions for automotive software process and certification. Automotive software must be dependable in harsh environments. MISRA-C provides a high design standard to reduce bugs in the development code. Automotive SPICE defines a process to track every line of code, from the requirements to the individual test which validates that line. Today I'm going to talk about how this impacted our team, how it might impact your team, and some of our recommendations from that experience. So I'll kick this off with a further introduction to Tuxera and our expertise in file systems and automotive challenges. The specific file system we developed for this environment is Reliance Edge, and I'll share our design goals for that project. One of those was to use MISRA-C 2012 as a coding standard. I'll talk about our findings with that project and suggestions for if you want to use this for your project. Along the way, a customer helped us decide that new processes were in order, so we adapted what we had to Automotive SPICE. Was the project worth it? I believe so, and I'll share my reasons in the conclusion. Tuxera, based here in beautiful Espoo, Finland, has 35 years of experience in file systems and flash media management. In addition to standard-based file systems like exFAT and NTFS, Tuxera has file systems which provide data integrity and reliability. These are comparable to Linux desktop file systems like ext4 and F2FS, but designed for an embedded environment, the automotive technology required for this audience. In addition to Linux, these file systems started on Windows CE and WinRiver VxWorks. Delivery operating systems now include QNX, Green Hills Integrity, and many others. Our core code is used across all of these environments and is flexible and adaptable to embedded systems. These are customer-focused solutions, enabling better lifetime, data integrity, and performance than standard file systems. One of the booming markets for data is automotive. With sensors and imaging and data logging, we work with car makers and Tier 1 suppliers to find the best performance, data handling, and storage solutions for those connected cars. Tuxera Reliance Edge, a refinement of our successful Reliance Nitro file system, was designed with these goals. A small footprint was the first design goal for two separate markets. Here, certification costs are measured in a cost per effective line of code. The market requirement for uptime is critical. Designs relying on this file system can't fail for corruption of data or lost system files. That applies equally to predictable data integrity, and the goal was to go further. It's entirely possible to predict the worst case I/O counts for every file system operation. Utilizing the proper copy-on-write design, updates and program changes could be handled seamlessly, always able to revert to a known good state in an interrupted operation. And finally, like all designs on flash media, lifespan is a critical measurement. Our customers need their products to last years, not months. Our development team estimated these design goals, added the estimate of using MISRA instead of our excellent in-house software design standard. Our experienced development team estimated that MISRA would add approximately 50% to the overall project timeline. So let's talk a little bit about MISRA-C. I'm going to break that down along with our thoughts from our team. That said, this is neither an advertisement for nor a class on MISRA-C. Don't expect to walk away from this discussion with expertise on this coding standard. MISRA is from the Motor Industry Software Reliability Association, a group that focuses on the software impact in automotive designs. The MISRA-C guidelines are an attempt to reduce the possibility of mistakes or bugs in the developer's code. The language subset's been improved through the years, moving from the 1990 ISO standard for C to the 1999 ISO definition. In a nutshell, the main focus for MISRA-C is strong typing, facilitating code safety, security, portability, and reliability. These guidelines look at where misuse of the language is common and where behaviors are undefined or unspecified. They are useful for initial development, but even more useful for future maintainers of the code. In addition to the coding and commenting standards, these guidelines give direction to understand how both the compiler and the static analysis tools respond to the written code. The first edition of these rules was available in 1998, followed by updates in 2004 and 2012. This third edition, most recent, introduces a new category of guideline, the directive, where compliance relates to process or procedural matters, and this ultimately connects back to Automotive SPICE. We adopted these guidelines for our product, primarily for the name recognition and the prevalence in the industry. Really, MISRA is a superset of our existing coding standards, and those were fairly strict. Our previous products were sold in source code format, and that software development kit is the product that we sell. The design goals for this product were similar, and so adherence to the standards would be easily judged by our customers. That may not apply for your project, and more on that later. Stepping back from the code, the starting place for MISRA designs are the requirements. Directive 3.1, which is required, is that all code shall be traceable to the documented requirements. We spent more time on that directive than on all the other rules and directives combined. MISRA-C does not dictate how this directive is to be accomplished, but it does provide this example, which we followed. One method of achieving traceability is to review the code against the corresponding design documents, which have in turn been reviewed against the requirements. Of course, to achieve this, requirements also need to exist. We settled on a three-tiered approach. The high-level requirements, briefly discussed earlier, are captured in the Market Requirements Document, or MRD. This describes the look and feel and the functionality of the product without specifying the specific design. From that document, we derived engineering requirements, encapsulated in the Software Requirements Specification, or SRS. This captures the market requirements into functional sections. Finally, the main design document, our Software Detailed Design, or SDD. Ultimately, less than 20 pages of market requirements ended up being roughly 200 pages of documentation and detailed design. This is the place that our team expected to spend the majority of the additional time. Related to this, of course, are also code reviews, which ensure that the file system code corresponds to that SDD definition. One side impact we noted from this, project changes have to be more planned and thought out and take longer. Fixing a small bug through code review connects to whether this wasn't specified well enough in the SDD, whether the function detail was lacking in the SRS, and can even come back to the planned use case in the MRD. The biggest piece of advice we've been able to share so far to the people we've talked with this about are related to Directive 5.1. MISRA should be adopted from the outset of the project. Quoting this document further, if a project is building on existing code that has a proven track record, then the benefits of compliance with MISRA-C may be outweighed by the risks of introducing a defect when making the code compliant. In such cases, a judgment on adopting MISRA-C should be made based on the net benefit likely to be obtained. Our MISRA-C project was written primarily from scratch, but we did take a small amount of existing code from a prototype and modified it for MISRA compliance. Based on that experience, we can definitely agree there's a high risk of introducing bugs. Many of the MISRA guidelines relate to control flow, expressions, and types. Existing functions can need extensive modifications to comply with these rules. When imposing MISRA compliance on an existing code base, it might be easier to review all the rules and determine project-wide deviations for certain rules. For example, there are many control flow rules that might mean drastic and risky restructuring of that code for compliance, but these rules are only advisory. As an example, let's consider Rule 15.1, the go-to statement should not be used. Rule 15.4, there should be no more than one break or go-to statement used to terminate any iteration. And Rule 15.5, a function should have a single point of exit. Refactoring an existing function to have a single breakpoint or a single exit is risky and can definitely introduce bugs. Someone who is intimately familiar with the code base should read the MISRA-C guidelines and flag the rules which are likely to be a problem. Then an informed decision can be made, whether to comply or to document and deviate. Another example of potentially impactful rule is Rule 21.3. This one is required. Prohibits dynamic memory allocation. Imagine refactoring an existing solution to remove that. You can see why these guidelines are much easier to adopt for a new project. Our team identified that MISRA is a mixture of common sense and bad ideas. Some of these rules sound good on paper but cause headaches in practice. If your team is like ours, there will be a temptation to deviate from many of these rules, even in a new project design. As I said, we deliver the source code as our product. Those deviations are quite obvious to our customer, assuming they are also familiar with MISRA-C. If your product is delivered in binary format, there's an even stronger temptation to add deviations. Most of the customers won't even see your code. Your development team has a coding standard already. It's good enough, right? Well, there's one more side effect to adding more deviations. And that side effect comes up with static analysis tools. The MISRA-C guidelines go into detail about the analysis done on the code, calculating the cyclomatic complexity and flagging potential problems. These tools are designed to work with MISRA-C code. Your documented deviations may be acceptable to the human customer reading the code to your development team, but the tools will just flag these as warnings, and every warning needs to be checked. When we started our project, we used PCLint and later migrated to Coverity. Regardless of which tools are chosen, there will be warnings to be checked. Some of these are false positives. Some lead to actual problems with the code. The false positives can be flagged, so that the warnings can be ignored later as long as that code does not change. Additional deviations will increase the warnings and, of course, the time spent analyzing each one. And finally, the reports on the outcome of the tools will need to explain what is found with each false positive. This can mean reports running to several pages. Not exactly easy to reflect on a simple dashboard. In short, every deliberate deviation adds to the workload for the project reporting. So for this project, we studied this up front, we read all the papers, all the documentation, and this was a brand new project. I mentioned that the team gave us our estimate of using MISRA would add 50% to the amount of time and effort. In the end, the project impact ended up actually being closer to 200%. Our project was initially designed to meet a new market need. In the process, we found customers who were interested and made sure to discuss their specific requirements related to MISRA. Doing that allowed us to make slight modifications to those internal requirements. And one example of those small adjustments was Automotive SPICE. What's Automotive SPICE? Well, in the last few years, the complexity of vehicle systems has increased enormously, bringing along increasing demands for environmental sustainability, safety, economy, and user-friendliness. Needless to say, innovation needs to happen at shorter intervals. Automotive SPICE. SPICE stands for Software Process Improvement and Capability determination. I don't know. Now, the challenge is how to properly develop a software-based solution with shorter development times, increased complexity, and higher reliability expectations. This is what Automotive SPICE is trying to solve by establishing a framework that should enable a proper development process. A-SPICE operates on two dimensions. First is the process dimension, which is inspired from a well-established software lifecycle process standards like ISO 12207. These define what needs to be done to properly produce a software module. Very important to note, it does not tell you how you should do it. The full A-SPICE consists of 32 processes for which automotive needs the VDA scope. VDA, by the way, is Verband der Automobilindustrie, the Association of the Automobile Industry. This association contains more than 600 companies. The processes we're talking about here run the gamut from supplier and contracts to design and quality assurance. For our project, we focused on the 16 key processes shown here. These encompass what is known as the HIS scope. Hersteller Initiative Software, also known as Manufacturer Initiative Software. The other A-SPICE dimension is maturity, also known as the capability level. This rates the maturity of the process on a 0 to 5 scale. On a 0, you have an incomplete or non-existent process. Level 1, you have processes in place and you use them. Level 2, the processes are in place and you're able to manage them. You monitor and track them. This is the requirement our customer established in terms of their software teams. They wanted all suppliers to be at level 2, and that was our initial goal. Level 3 is about being able to have your processes customized for every single project you do and keeping them monitored and controlled. Level 4 is when your processes also allow you to predict the outcome of the process. And level 5 is when you're then adding a continuous loop of improvement to your processes. A first hurdle encountered by the organization is misunderstandings and wrong interpretations. A lot of times it's seen as a burden to operations, an increase of documentation needed throughout the whole process, from business acquisition all the way to final delivery. And then it's about how to collect that data and how to use it to properly evaluate if the right things are being done in the right order and correctly, and what to do if things don't work out the way they should. We didn't really have a problem with organizational resistance. We had a customer who was interested in this result. What we did find was we needed a change in our organization chart. Our software test team was part of the engineering team. I'm sure they are in many organizations. In our relatively small company, we would listen to them as part of the test cycle, holding shipment as necessary to fix the bugs. But organizationally, they reported to the head of engineering, which means if the head of engineering decided, management team above that perhaps, that the software needed to go out, they could technically override the test team. The quality organization needs to be in its own vertical to make Automotive SPICE truly work, reporting at the same level as the head of engineering. They have to have that ability to stop the release if it does not meet quality standards. Our team had a somewhat mature process which incorporated many of these goals, but our naming conventions were ad hoc. There was little understanding of the differences in the process and very few resources to help our team. In our attempt to make sure we met the goals before our first assessment, we ended up overcomplicating some of those processes as well. One anecdote here, we were surprised to find that we had a lot of undocumented knowledge. The examiners put it very bluntly. What would happen if this or that team member was struck by a bus? Wow. While eye-opening, we got the point. We needed to document all of our procedures. We came up with a better question too. What if they won the lottery? Anyhow, to automatically and properly work with Automotive SPICE, the team has to be able to react to a situation with only the documentation on hand. After our assessment, we started activities to fulfill the different process needs. Very quickly, roadblocks were met with no proper understanding and less resources available. At an organizational level, we decided to do formal trainings in order to better understand that topic. And that turned out to be a definite plus, because things could be then simplified and translated to our own culture and language. I've heard it said that a successful A-SPICE implementation is a balancing act into what is really needed and how you can effectively efficiently do it within your organization. There's no magic recipe. It takes time and learning, trial and error before getting it right. Our preliminary audit was in May of 2019, and we were fully prepared for the second audit later that year. On this graph, N is for no process in place, P is for a partial implementation, L is for largely implemented, and F for fully implemented. The results of our first assessment, well, few processes were fully implemented, a few more were largely implemented, but we hadn't completed that organizational change for independent quality. Once we had that in place, we were definitely moving in the right direction. Improvement continued, and at our most recent checkpoints, we had closed nearly all of the items identifying as needing correction. One more anecdote. I mentioned the formal training and learning this new language. Ultimately, our head of engineering took the training to become an A-SPICE assessor. So the results of our team's hard work are in. As of just a few weeks ago, the 1st of December 2022, we have 5 processes at level 1 and 6 fully at level 2. We expect that by our next assessment, we might be able to meet our customers' goal of full level 2 across the board, and maybe future customers as well. I mentioned the tools earlier too, especially software analysis having to do with MISRA-C. These tools deal directly with the code. For Automotive SPICE, tools can be helpful also. These are process tools, dealing with everything from storage of the code to the process documentation. Reporting is an important step, and process tools provide several helpful dashboards, status update at a glance, with the ability to drill down when necessary. I separated traceability because what we're really talking about here is tracing from the original requirement all the way to the test for an individual line of code. Software analysis tools can answer whether the code section has a unit test, but they can't read the requirements and the design documents, and they definitely can't report on them. I said we'd come back to the conclusion here, asking the question, was it worth it? The short answer is definitely yes, and I expect plenty of our future automotive customers will agree with this. The basic goal of MISRA-C 2012 is to prevent bugs, or to at least push bug discovery to an earlier and ideally less expensive portion of the process. This is BAM's classic chart of the average cost to fix a bug. And some recent debate has questioned whether bugs found in deployment are really 100 times as expensive to fix. However, everyone agrees that earlier is still cheaper. MISRA requires design analysis, and this forethought and planning does not stop creation of clever code. When a bug is found, the process provided by Automotive SPICE helps line that bug up. Was it from a design flaw? How can we correct the bug without changing the way the function works? Or should the design be changed to handle this unexpected situation? Proper implementation of Automotive SPICE requires an organization-level commitment, with quality reporting at the same level as design and engineering. Training and documentation are needed for all appropriate staff members so those lottery winners can be replaced when necessary. And finally, we talked about all the tools we now use to manage activities, especially full traceability. As stated earlier, our goal was future certification. Reliance Edge has a full set of artifacts available to help with DO-178 or other certification, and MISRA-C 2012 enabled half of those artifacts as a matter of course. By keeping our code tight and minimizing dead code, this product is more easily verifiable by a certification team. We've also decided to release this product as an open source project that is dual licensed under GPL v2 and commercial licenses. This helps developers kick the tires, even if they can't comply with the GPL v2 restrictions in their shipping product. One note of caution though, I've had at least 2 different folks download the GPL version of the code and run it through their Automotive SPICE checker and say, wow, there's failures. Turns out they were testing their test code. Our test code, which is for test and validation, doesn't meet the MISRA standards completely because it does things like, allocate memory on the fly. It's a test code. Anyhow, the processes that we have in place for Automotive SPICE would also apply to medical SPICE, and for that matter, can aerospace be far behind? Our goal here was to create the best possible file system software component for the automotive industry, and yes, these steps were definitely worth it. Reliance Edge with full Automotive SPICE and MISRA-C has been re-released as Reliance Assure. If this product is of interest to you or your team, please reach out to us for more information, including samples of those related documents. I hope you found today's presentation both informative and interesting. Thank you for attending.